Okay, so today we are going to solve the back questions of chapter 11 thermodynamics. So the first question is distinguish between the terms internal energy and heat energy. So internal energy means the total kinetic and potential energy of the molecules of a system. So the whole kinetic and potential energy is known as internal energy, and it depends upon the state of the system. That is, it depends upon factors such as temperature, pressure, volume, and all. Then heat, and it is represented as U. Heat energy means it is the energy which flows from one body to another due to temperature differences. And it is the form of energy in transit, and it does not depend upon system state. That is, it does not depend upon the factors such as temperature, pressure, volume, and all. And it is represented as Q. That is the difference between internal and heat energy. Now, the next question is, what do you mean by an indicator diagram? Derive an expression for the work done during the expansion of an ideal gas. So, an indicator diagram means it is the graph which shows how the pressure varies with volume or how it is different with volume. So, the derivation is first is work done in gas expansion, that is W is equal to integral P dV. Here, when it is for an isothermal process, we will be using ideal gas equation, that is PV is equal to nRT. PV is equal to nRT. Then we'll substitute the value. So W is equal to nRT log Vf by Vi. Then when there is no heat exchange, so no heat exchange means adiabatic process. Adiabatic process. So for the adiabatic process, that is when there is no heat exchange, W will be equal to PiVi minus PFVF by rho minus 1. So the adiabatic index is rho. Index is rho. The next question is, define the temperature using the zeroth law of thermodynamics. So the zeroth law of thermodynamics is if two systems are in thermal equilibrium with the third system, they are also in thermal equilibrium with each other. So basically this states that if two objects are at the same temperature as a third object, then all the three will be at the same temperature. So we can say that temperature as the property, it describes if two objects are in thermal equilibrium, then there is no heat flow between them. And therefore, the third object will also be in the same temperature, that is in the same equilibrium. That is what zeroth law of thermodynamics states. Next question is, state the first law of thermodynamics and its limitations. So the first law of thermodynamics is the heat energy supplied to a system is equal to the sum of change in internal energy and work done by the system. So the heat supplied to a system, so the heat energy is Q. It is equal to the sum of the change in the internal energy. Whatever the internal energy is there, the sum of the change in internal energy and the work done by system. That is first law of thermodynamics. And the limitations or the disadvantages is that it does not tell the direction of heat flow. First one, we cannot say what direction the heat is flowing. Then it will not explain why some processes are irreversible. And it does not give information about the efficiency of energy conversion. So the limitation is does not tell the direction of heat flow. Direction of heat flow. Then it does not explain why some processes are irreversible and it does not give information about the efficiency of energy conversion. Okay. Next question is, what is the difference between isothermal, adiabatic, isobaric, and isochoric processes? So isothermal means temperature will be constant. So T is constant and the equation is PV equal to constant. Adiabatic means there is no heat exchange. So we can say that Q is equal to 0 and the equation is PV raised to rho is equal to constant. Whereas isobaric is pressure is constant. So P is constant and isochoric volume is constant. So that is why V is equal to constant. So isothermal temperature remains constant, isobaric pressure remains constant, and isochoric volume remains constant. Adiabatic means there is no heat exchange. And these are the equations. PV is equal to constant, PV raised to rho is equal to constant, V by T equal to constant, and P by T is equal to constant. Next question is, state the second law of thermodynamics. So there is two statements. One is by Kelvin Planck statement and the other is Closure statement. So Kelvin Planck statement is, it is impossible to extract heat from a single reservoir and convert it entirely into work without any other effect. So it explains that we cannot create a machine that takes heat from a single source and convert all of it into work, because whenever you are creating something, heat will be lost. That is what Kelvin Planck statement says. Closure statement says that heat cannot flow from a colder body to a hotter body without external work being done. So it explains that heat cannot move from a cold body to a hot object by itself. You need to give some external work in order to make that happen. Example is fridge. That is, fridge needs electricity to keep things cold. So we are providing some external work in order to make it happen. So these are the two laws of second law of thermodynamics: Kelvin Planck statement and Closure statement. Next question is, discuss reversible and irreversible processes with examples. Reversible process means it can return to its initial state. That is how it was before, it can come back to that state without any change in the surroundings. And this happens slowly and in an equilibrium. Example is Carnot cycle. Whereas irreversible process means it cannot return to its initial state without changes in the surroundings, and it happens very fast, involves friction, turbulence, heat loss, and all. Example is sudden gas expansion. So reversible means it can return to its initial state, irreversible means it cannot. Reversible happens slowly without any changes in the environment. Irreversible happens quick with changes in the surroundings. Next question is, explain Carnot cycle, use the indicator diagram to calculate its efficiency. So Carnot cycle has 4 steps. Sorry. Isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. So these are the 4 steps. Isothermal expansion means heat is absorbed from the source. So from a source, heat is absorbed. That is isothermal expansion. Adiabatic expansion means the gas expands without heat exchange. So there is no heat exchange, but the gas is expanded. Then isothermal compression means heat is rejected to the sink. Heat is rejected to the sink. Adiabatic compression is the gas is compressed without heat exchange. Okay, so these are the 4 steps. So isothermal expansion is heat is absorbed from the source. Then the gas will expand without any heat exchange, which is known as adiabatic expansion. Then heat is rejected to the sink, that is isothermal compression. And the gas is compressed without heat exchange, that is adiabatic compression. And the efficiency formula is N is equal to 1 minus T2 by T1. Here T2 is the sink temperature. T2 is the sink temperature and T1 is the source temperature. Next question is, calculate the change in internal energy of a system when system absorbs 2000 joules of heat and produces 500 joules of work. The system absorbs 1100 joules of heat and 400 joules of work is done on it. Okay, so first equation is, that is we are using first law of thermodynamics. Delta U is equal to Q minus V. Here, Q in the first sub question, Q is given. Okay, that is 2000 joules and W is 5000 joules. So here we can just substitute it directly to the equation. Delta U is equal to Q minus W. So you will get the value as 1500 joules. The second sub question, W is minus 400 joules because it is given the work is done on the system. And that is the reason why negative sign key. Okay. So here also, when you substitute it into the first law of thermodynamics, the value is 1500 joules. So we can say that in both the cases, the change in internal energy is 1500 joules. Next question is, a Carnot engine whose temperature of the source is 400 K takes 200 calories of heat at this temperature and reject 150 calories of heat to the sink. What is temperature of the sink? Calculate efficiency. So the first given thing information is T1. That is the source temperature is given 400 K. Then Q1 is given 200 calories. That is heat absorbed and heat rejected. Heat absorbed is Q1. Heat rejected is Q2. 200 calories and 150 calories. So we need to find T2, that is sink temperature of the sink. So according to the efficiency equation, N is equal to 1 minus T2 by T1. We can also express this equation as N is equal to 1 minus Q2 by Q1. So this is the efficiency equation, but we can also express this as N is equal to 1 minus Q2 by Q1. We have the values for Q2 and Q1 substituted, so you will get a value that is 0.25. That is N. Okay, so now you can substitute these values into the efficiency equation. So N, that is 0.25 is equal to 1 minus T2 by T1. T1 is given in the question, that is 400. So when you solve this, you will get the value of T2 as 300 K. Now we need to find the efficiency. In order to find the efficiency, we already found N, right? So now you need to multiply it with 100 in order to get the percentage. So N into 100, that is 0.25 into 100 is 25%. This is the efficiency. With that, we finish the back questions. Thank you.